Hello. So for the chemistry of copper, there's not a lot of calculations, in this particular lab, but there are things concerning oxidation numbers, and some of them can be confusing. So I'll just go over a couple of the rules here and try to work through some of these things. So the first reaction that you're doing, you have the copper metal and you add nitric acid. That forms copper nitrate plus 2NO2. This is the gas that is given off. And then you also get water. So copper, if we look at the oxidation rules, is in its elemental form and it's a solid. So that means the oxidation number is 0. So only one kind of atom is present, so there's no charge there. So again, your oxidation number is 0. The oxidation number of copper in copper nitrate, you have copper plus, this is the polyatomic anion. If you remember the polyatomic anions, that one is nitrate. So nitrate has a -1 charge. So this is overall -1. So you're going to treat this as a polyatomic ion and not N and O individually. So you're going to treat this as a unit. So as a whole, this is -1. There's 2 of them, which makes it -2. -2. So this has to be +2. So copper on this side is +2. So again, the nitrate by itself is just -1, and then there's 2 of them here, so that equals -2, so that has to be +2. So when we're going from copper 0 to copper +2, it's becoming more positive. Which means that it lost electrons, because electrons are negatively charged. So if it's losing electrons, that's going to be an oxidation. So again, you have oil rig. So oxidation is loss or reduction is gain. So if you're losing electrons, as we are here, that's oxidizing. Or if you like Leo the lion goes grr. Loss of electrons is oxidation, gain of electrons is reduction. So you can use both of those things to kind of help you out. Okay, so that's how you can figure out the oxidation numbers. Again, so you have these different rules here. The ones that you want to pay attention to really are the elemental form and then the ionic compounds, because a lot of these are ionic. The sum of oxidation number of atoms in an ionic compound is the charge on the polyatomic ion. So if you had something where you made zinc sulfate, you want to treat sulfate as one whole thing. So sulfate has -2, so this zinc has to be +2 in that case. So that's how you would do these with the polyatomic ions. Okay, this is later in the experiment, maybe the next step, but if you were going to do the total ionic equation for this reaction, you want to break up all the things that are dissolving or dissociating into the solution, which are all the aqueous components, and those will be broken up into the ions. So for copper, we have copper, we already said that was 2+, so we indicate the charge and also its state, which is aqueous. Nitrate has a minus charge, and there's 2 nitrates, so you want to put the 2 out front. We have 2 sodium ions, which are positive, that's aqueous. We have 2 OH minus ions, which are also aqueous. Copper hydroxide is solid, so that stays together. And then we have 2 Na plus and 2 NO3 minus. The NO3 has this coefficient of 2, so there's 2 Na and then there's 2 NO3 minus. So now to get the, to get to the net ionic equation, we remove all of the spectator ions. So NO3 appears on both sides, and there's 2 of both of them that cancel out, and there's 2 sodium ions that will appear on both sides. So your net equation will be Cu plus 2 plus 2 OH minus, and that gives copper hydroxide, and that's a solid. So that's how you get to the total ionic equation. So if you have things like water in the equation, that doesn't show up in the net ionic equation. and you don't have to dissociate gases either. So it applies to the aqueous, and solids will stay put.